For a discrete random variable x, the cumulative distribution function is the probability that our random variable is less than or equal to our argument, which we can compute by summing the probabilities that our random variable is equal to xi for all xi less than x. Now, when we move to continuous random variables, remember that a sum is an integral. So for a continuous random variable, the cumulative distribution function will be, which we can compute by evaluating the integral from minus infinity up to x. Since, generally speaking, calculus is easier, it's usually easier to find the CDF for a continuous random variable than a discrete random variable. For example, let's find the CDF for the exponential distribution. So since x must be greater than or equal to 0, the probability that x is less than 0 is going to be 0. And so our CDF will be 0 for all x strictly less than 0. And that strictly less is going to become important later on. Now, suppose we have something that's greater than or equal to 0. Well, that's when our PDF is non-zero, and so the probability that we're less than or equal to x is going to be the integral of our PDF, which will be or suppose our PDF is a little bit messier, and here we'll actually leave our C be unknown. Let's find our CDF. Since the probability is 0 for any x not in the interval from 0 to 10, then we know that the integral over this interval has to be 1. Since outside the integral is going to be 0. Since the function is piecewise continuous, we can split the integral. But this integral over a single point is going to be 0, and so this becomes, and so that means C must satisfy the equation, and so we solve for C and find, and so our PDF will be, since the boundaries are at x equals 0, 4, and 10, we can split the cumulative distribution function into integrals up to each boundary point. For x strictly less than 0, our CDF will be, but since we're assuming x is less than 0, then on this interval, f of x will also be 0, and our integral will be, next, over the interval between 0 up to but not including 4, our integral will be split between minus infinity to 0 and from 0 to x. And in the first interval, our function is 0, and in the second interval, our function is, and we can evaluate to get, now, note that if we include x equals 4 in our integral, our value doesn't actually change because we have a piecewise continuous function, and adding a single point doesn't change the integral value. We'll see why that's important in a moment. For the interval between 4 and 10, we can split the integral into, but we already know the value of the first integral, so that's going to be our CDF at 4, 0.1, and so we only have to worry about that second integral, which will be, and note that f of 10 is 1, so the CDF can't increase for higher values. And the probability that x is greater than 10 is 0, so the CDF won't increase for higher values. And this check is important because while the algebra may be correct, it's nice to have some evidence from the probability that that's what's actually going to happen.